Hi, welcome to Nomis Academy. This time we will be dealing with sequence, but geometric sequence. Geometric sequence. So let us deal with geometric sequence, just like arithmetic sequence or progression. Call it progression, call it sequence, it means the same thing. So just like geometric progression now, geometric progression is an order of list of numbers that follow a regular pattern by product. I mean multiplication. So it's either multiplied by a whole number or by a fraction. Let's see what we're talking about geometric progression. Geometric progression. Geometric progression. So take a look at this number. Let's say we have 2, and the next number now is 4, and the next number is 8, the next number is 16, the next number is 32. So study this is added up, or let me say this increases by multiplication of 2. 2 times 2 gives 4, 4 times 2 gives 8, 8 times 2 gives 16, 16 times 2 gives 32. So you can't tell like arithmetic progression to say that they are adding up by 2, because if we have 2 plus 2 we have 4, but 4 plus 2 will not give us 8. So this is not additional progression. So it is by multiplication of 2. 2 times 2 gives 4, 4 times 2 gives 8, 8 times 2 gives 16, 16 times 2 gives 32. So in this case of progression, we can name it geometric progression. Now let us get to know, what if I'm being asked, because if this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term, what if I'm being asked of the 100th term? Would I have to continue listing on my books, or start thinking of multiplying by 2, multiplying by 2, multiplying by 2, and I might get stuck? So let us see if we can derive a formula to calculate geometric progression of any term, of any term, of any term, even be it 1000th term of that progression. Let us see if there is a formula that we can use to calculate it. Now, when we come to geometric progression, we can tell that the difference between this and this is multiplication of 2, right? And if you check this one too, it's by multiplication of 2. So for us to know the difference, here the difference is, let's say, 4 divided by 2, because we know it is multiplied by 2. So we definitely have 2. Okay, what about 8 divided by 4? We definitely have 2. Okay, what about 16 divided by 8? We still have 2. Okay, what about 32 divided by 16? We still have 2. So this 2 now, you see, is gotten by ratio. Is gotten by second term divided by first term. Again, I can say third term divided by second term. And also, fourth term is divided by third term. So that 2 as an answer we get is known as common ratio. I call it common ratio. So in this case, it is a ratio. So the ratio of a progression is 2. That is 2 over 1. You can call it 2 ratio 1, 2 over 1. So the common ratio is 2. So the sequence progresses by the common ratio of 2. So when I now study it, if I have 2 and I have 4 and I have 8, so my first term is, let's take it as our A, just like arithmetic progression. So the second term becomes A multiplied by 2, right? And the third term is A multiply by what now? Multiply by, should I say 2? So A is now first term, multiply by 2 times what now? Times 2, right? 2 times 2. So the fourth term is now still A, multiply by 2 times 2 times 2. Am I getting it right? So because our A here is 2, 2 times 2 is 4, times 2 is 8, right? So the fourth term, which is 16, is now A, multiply by 2 times 2 times 2. So when we study, let's study from this fourth term. This fourth term now says that A multiply by 2 raised to the power of 3. Wow, 2 times 2 times 2, that's 2 raised to the power of 3, fourth term. So if I check the fifth term, definitely the fifth term will be A multiplied by 2 raised to the power of 4. So that tells that the nth term of GP is equal to, let's say the nth term of GP is equal to the first term multiplied by the common ratio R. Let's donate the common ratio with what? R. And then this is 4. So when I'm looking for the fifth term, this is 4. When I was looking for the fourth term, this is 3. That means the nth term will be subtracted by 1. So to be n term minus 1. So from there we derive a formula to calculate geometric the n term of a geometric progression. So let's get that formula installed. The nth term of a GP is equal to A, the first term, multiplied by R, that is the common ratio, n term minus 1, and that is the formula to calculate the n term of any geometric progression. So let's take an example. Example number 1. Find the sixth and the 10th term of a GP 3, 9, 27, 81. So it continues like that. So let's get into the solution. Having known the formula, to be easy for us to get it, that the n term of GP that we are solving here is A R n minus 1. So we are looking for the sixth term. So the sixth term is equals to the first term here is 3. Now what is our common ratio? Common ratio is second term divided by what now? First term. And third term divided by second term. So by the time you have 9 divided by 3, you should have 3. 27 divided by 9, it is 3. 81 divided by 27 is 3. So the common ratio is what? 3. So multiply by 3. Now n, the sixth term, minus 1. So we now have 3 times 3 raised to the power of 5. So this is 3 times 3 raised to the power of 6, right? So you can just say 3 times 3 times 3 times 3 times 3 times 3. So for me to make it easy, I can make this 9, multiply by 9, multiply by 9. So I now have 81 multiplied by 9. So I'll have 729, right? Because 9 times 1 is 9. 9 times 8 is 72. So the sixth term is 729. The sixth term of this GP is 729. What about the 10th term of this GP? The 10th term of this GP. So let's do this by the side. the 10th term of the GP will be 3 multiplied by 3 raised to power of 10 minus 1. Yes, clearly. So that will be 3 multiplied by 3 raised to power of 9. So having known this, I can just split it to be 3 multiplied by, remember that this is 3 raised to power of 6. So I can say 3 raised to power of 6 multiplied by 3 raised to power of 3 to make things easier for me to get. So that will be 3 multiplied by 3 raised to power of 6 is actually 729, and 3 raised to power of 3 is 27, because that is 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So I can say 27 times 3 is 81. So I now have 729 multiplied by 81. So for the sake of those that could calculate without calculator, so let's try it out. 729 multiplied by 81. So you have 729. 8 times 9 is 72. You have 7. 16 plus 7 is 23. So you have 3 remainder 2. 8 times 7 is 56. 56 plus 2 is 58. So we have 58. So when we add up, we have 94095. So that's 59,049. 59,049. 59,049. So that is the 10th term of the GP that we have the sequence to be like this. I hope you understood what we did in this video. Check it well again, and then make sure you get them installed in your memory. Bye bye. See you in the next video.